All right. So again, we have find the slope of the tangent lines to f of x equals e to the x at the points 0, 1, and 1e. So if we want to find the slope of the tangent line, that just means we need to find f prime evaluated at these two values of x. Okay. So if our f of x is equal to e to the x, we want to evaluate these at the points at the point 0, 1 and 1, e. So we want to find the slope of the tangent. All that means is we need to find f prime evaluated when x is 0 and x is 1. So f prime of x is just going to be e to the x. So then f prime of 0 is going to be 1. F prime of 1 is going to be e. Okay. So at the point 0, 1, the slope of the tangent line is 1. At the point 1e, the slope of the tangent line is e. So then what conclusion can we make? The slope of the tangent line at a given point is going to be the y value of that point. Okay. So again, if we're finding slope, that just means if we want to find the slope of the tangent line, that means just look at your f prime. So we looked at f prime of 0 and f prime of 1. Again, we said f prime of 0 is 1, f prime of 1 was e. Again, e to the x is its own derivative, so f prime of e to the x is, or your derivative of e to the x is e to the x. And we found these values. Again, the conclusion that we can make is that the slope of the tangent line of a point is just going to be the y value of that point. The y value here is 1, the slope is 1. The y value here is e, the slope is e. Okay. So with example 2. So with example 2, we just want to differentiate each function. Okay. So for part A, we have f of x equals e to the 2x. So we have f of x equals e to the 2x. So then our f prime, so here we use a chain rule. The derivative of e is just going to be itself times the derivative of this exponent. So the derivative of 2x is just 2. So then that's just 2 times e to the 2x. Part B. F of x is e to the minus 3x squared. Okay, so for part B, we have f of x is e to the minus 3x squared. So if we want to find a derivative, we're going to use the chain rule here. So so my f prime is going to be just your e to the minus 3x squared times the derivative of this exponent here. The derivative of a minus 3x squared is going to be minus 6x. So it's going to be e times this minus 6x. So then our final is just going to be a minus 6x times e to the power of a minus 3x squared. So then for part C, we have f of x is equal to 6e to the x squared, 6 times e to the x squared. So then our f prime is going to be, you have a constant times your function, so it's still just going to be that constant times, now the derivative of e is itself, e to the x squared, times the derivative of x squared is 2x. So then this is just 12x times e to the x squared d. We have f of x is e to the minus x. So then our f prime, again, it's just going to be e to the minus x times your derivative of your exponent. It's just going to be a minus 1. So then that's just going to be a minus e to the minus x. Okay. So for part 3, it's the same notion as example 3 is the same notion as example 2. So again, just applying your usual rules for differentiation, and let's see what happens. Okay, so example 3. Say part A. Our f of x is x times e to the x. So you should see you're going to need the product rule here if you want to take the derivative. So our f prime is going to be, so the first times the derivative of the second plus the second times the derivative of the first. So my first is x times my derivative of my second is just e to the x. So my first times the derivative of my second plus my second times the derivative of my first. So that's times 1.